Hi and welcome back. Today our topic is endpoint vulnerability attacks and defenses. Now we'll be tackling an important aspect of cybersecurity endpoint vulnerabilities. Endpoints such as desktops, laptops, mobile devices, and devices which are connected to our network are the frequent targets for cyber attacks. Now, understanding the vulnerabilities that affect these devices is crucial for safeguarding our personal and professional data. So, we'll be exploring some of the important topics which falls under the category of endpoint vulnerability attacks and defenses. So, if we look at the endpoint vulnerability, let's try to understand what is an endpoint vulnerability. The fundamental weakness in a software or hardware that can be exploited by an attacker to gain unauthorized access or which can cause a harm to your network is an endpoint vulnerability. Now, as we discussed earlier, that our computers, laptops, mobile devices, any devices which are connected to the network, they can be our endpoint vulnerabilities if they are not being taken care of in a proper way. Now, there are lots of different components of it, so I'm just listing them over here, and I'll be explaining with the passage of time what are they and how can we protect it. Now, first of all, we have unpatched softwares that has not been updated with the necessary security patches, leaving the vulnerabilities unaddressed and exploitable by the attackers. So whenever we are talking about endpoints, it's not only about the operating systems, but it's also about the applications that we are using or the software that we are using on our organization. For example, if you're using an Oracle database and it has not been patched and there were some vulnerabilities which were identified in that, it's our responsibility to include it as part of our patch management program, where we will make sure that all softwares and hardware, whatever we are using in our organization, are properly patched. Then we have misconfigured systems that are set up with proper security, are set up without proper security settings, often due to default configuration, are being left unchanged, which can provide easy access points to the attackers. Now, you might have seen that your router comes in, the one that you're using at home for internet, comes in with the default username and password. Same is the concept, like any network devices that we purchase, they come in with the default username and password. So once we are implementing that stuff on our network, it's our responsibility to make sure to change their default IP addresses and the username and password, so that if somehow your network is compromised, no one could access those devices with the default username and passwords. Insecure operating systems that are outdated or lack sufficient security features and updates, making them more susceptible for various type of cyber attacks. Now, maybe you're using an operating system, let's say Windows 7, which is end of life, end of support, but you have an application which works on Windows 7. Now, there is no way that you can get rid of that operating system, because otherwise your application would stop working. So in order to use the same system and Windows 7 in your organization, there are different controls which we call as compensating controls. We use it just to make sure that we'll isolate that operating system from the rest of the environment, means that it won't have a direct connectivity with the outside internet, but we can still use those operating systems. Lack of endpoint protection tools, the absence of inadequate use of the security tools such as antivirus, anti-malware, and firewalls and endpoint devices, which increases the risk of malicious attacks. So we must have some endpoint security things. You might have seen it in your organizations that you're using a corporate antivirus or anti-malware with the firewalls, etc., just to protect the systems. User privilege mismanagement, excessive use of privilege or inadequate control over the access rights can lead to misuse or unauthorized access, often exacerbating the impact of the attack. Now, that happens that if we are giving an admin access to everyone, so you might have seen in organizations we don't give admin access to the users, so that we can keep control of the applications which should be installed on those systems and which should be used for official purposes. Otherwise, people would start installing all sort of applications which might be purchased, or they might get it from some rogue sources, and we want to prevent it from happening. Then we have poor authentication methods, weak or insufficient authentication methods, for example, lack of multi-factor authentications that make it easier for unauthorized access to gain access to the systems. So nowadays we need to have layers and layers of protection. So in order to verify that that's the user who's logging into the system. So other than username and password, we have multi-factor authentication, just like Google Authenticator, that even after providing a username and password, it would challenge you to enter a secure code which appears on your Authenticator app. Only then you'll be able to log into those systems. Then we have physical security weakness, inadequate, or the physical security measures that allow unauthorized physical access to the devices, potentially leading a data theft or device manipulation. So we don't want any users to just walk in the sensitive areas, play around with our devices. We don't know what they are doing. Maybe they'll connect their own devices, they'll capture the packets, or maybe they'll try to disturb the overall infrastructure and the services which are running over there. So physical security controls are really important. Use of unsupported hardware, utilizing or outdated, no longer supported hardware that does not receive security updates or patches, leaving unknown vulnerabilities are usually unaddressed. Now, if you are using unsupported hardware, for example, if you have purchased a server rack for some Blade servers and it's outdated, it's end of service, end of life, and you're not even getting the replacement parts for that, it would stop working anytime. Maybe there would be some vulnerabilities which would be identified in the firmware of it, but since it's outdated, the vendor is not providing the firmware updates. It's just like you are waiting for an attack to take place on your network. Then we have network exposure, devices directly exposed to the internet without adequate security measures, which can easily be targeted by external attackers. So if we have certain servers which are facing the external world like the internet, and you're running services like maybe the web servers or your exchange servers where it is used to exchange emails, etc., you need to allow only those ports which are required for those services. Otherwise, rest of the services should be blocked from the external access, so that people cannot gain access to the systems by the ports which are not required but are open for any other person from external entities to gain access to those systems. Then we have phishing susceptibility. It is the vulnerabilities which is related to user behavior, where users are tricked into providing sensitive information, downloading malware, or through the deceptive email messages which you'll receive. We covered it as part of social engineering attacks as well. Now, there is a threat landscape, the range of the potential threats that target endpoint devices, characterized by the current and emerging security challenges. Now, we have different things in this one. For example, malware, first of all, malicious software designed to disrupt, damage, and gain unauthorized access to computer systems, including viruses, worms, Trojans, and ransomware, etc. Now, all of these things falls into the category of a malware. We'll be covering it shortly, but at the moment, the threat landscape always includes the malwares which can cause a potential threat to your organization. Then we have phishing attacks, deceptive attempts to steal the sensitive information such as username and passwords, credit card details, or any trustworthy entity or the electronic communications. Now, what happens in phishing attacks is that maybe you'll receive an email which would have a similar format of the emails, the kind of emails that your organization would send in a format. You'll receive an email that we have seen that your account has been compromised and we highly urge you to change the password. Click here to change the password. Now, once you'll click on that link, it would take you to a lookalike website which looks similar to your password change thing. So you'll enter your current password and the new password. So they'll capture those details and it would be later used in order to access your email and other related services. Now, advanced persistent threats are the prolonged and targeted cybersecurity attacks in which an intruder gains access to the network and remains undetected for an extended period of time. Now, for APTs, it takes time to gain access to the systems, but usually they are targeted to the to anything which is of a national interest to any country. For example, if country X wants to attack the national grid system of country B, they would use advanced persistent threats so that they have an access to their system and they can see that what kind of activities are going on, and they can even steal the top priority or the top secrets from that organization or countries, and then they'll be posted on public websites just to show that they gained access to the systems. Now, zero-day exploits are also there. They take advantage of previously known vulnerabilities in a system, software, hardware before the vendor issues a patch and before a vulnerability becomes widely known. So, for example, if you are using an operating system and all of a sudden there is a vulnerability which has been identified by a group of hackers or anything, so they'll search for all the organizations who are using that specific operating system and they'll approach them by sending them emails that we can see that there are certain vulnerabilities found, and these are the screenshots of your system. So if you'll not pay us this much, or you'll not agree to our terms and conditions, we'll delete the data, or maybe we'll encrypt your systems. Now they are called zero-day exploits because the patches or the cure for those vulnerabilities has not been released by the vendors, so they try to take advantage of that time to exploit the systems which has those certain vulnerabilities. Then we had denial of service attacks intended to shut down a machine or a network, making it inaccessible to its intended users by flooding the target with the traffic and sending information that triggers a crash. Now you might see some videos on our channel on distributed denial of service attacks where we are practically showing that how does it take place, but it's just like overwhelming the resources of a system and making sure that those systems are not accessible to the public. Then we have man-in-the-middle attack, an attack where the attacker secretly relays and possibly alerts the communications between two parties who believe they are directly communicating with each other. So there would be a person who will maybe capture the packets in between. They would modify it and then send it again. So they are capturing the communication which is taking place between the two parties, maybe with the modified communication which would be injected on your network. Then we have ransomware attacks. You might have heard of WannaCry, etc. It's a type of malicious software that's designed to block access to computer systems until a sum of money is paid. So they'll encrypt your systems and they'll ask for money. If you'll not pay for that, or if you'll not cooperate, they'll encrypt the entire system and there's no way that you can recover that. But it's never a good option to pay the ransom amount, because it has been noticed in a number of times that even if you'll pay the amount, they'll never release the decryption keys in order to unlock your systems. Then we have insider threats, risk imposed by individuals from within the organization, such as the employees or the former employees, contractors, or business associates who have inside information concerning the organization's security practices, data, and computer systems. So any person who's working within your organization who are not happy with the policies, etc., they could be an insider threat who can tell the vulnerabilities of your systems to your competitors, and then they can target the systems accordingly. Now there are different kind of malware attacks. We have spyware, Trojan, rootkits, worms, fileless virus, then logic bombs, backdoors, bots, keyloggers, rat, and bloatware. So we'll try to understand it one by one. Spyware, first of all, it's a malware that secretly observes the user computer activity and collects the personal information. For example, the keyloggers, if they are installed on your systems, maybe they'll be capturing all the keystrokes that you'll have on your keyboard, and they'll be sent to the person who has actually deployed that spyware on your computer. Then we have a Trojan, a malware that is disguised as a legitimate software but performs malicious actions once activated. So it's a fake antivirus program that is installed as a malware, or maybe if you have downloaded an audio or a video file from the internet, so the time when you're enjoying that movie in a full screen mode, it would be uploading something or performing certain operations in the background. Rootkits are the software tools that enable administrator level access to a computer on a network. Rootkits that mask the presence of other malware. So it's kind of a backdoor entry which would be there. It would wait for the instructions to perform certain actions on your computers. A worm is a malware that replicates itself to spread to other computers, like email worms that spread by sending copies of themselves to the contacts which you have in your contact list. Then we have fileless virus. It's a malware that operates without creating or altering any files. So exploiting the vulnerabilities in an already installed softwares, it would be looking for that and it would exploit that. Then we have logic bombs, which are the malwares triggered by specific conditions, a program that delete files on a specific date. So maybe a person who wasn't happy with your organization and they left, maybe they would install a logic bomb on your system. So after a certain time, maybe it would start deleting the tables from the databases, or it would delete the files from the web servers, and so on. Now, there are backdoors, a method by bypassing the normal authentication procedures. Softwares update that are unintentionally introduced backdoors. So it would open an access or a port on your system through which any attacker externally can gain access to your systems and can make the necessary changes. Then there are bots, which are software applications that perform automated tasks over the internet. Bots are used in DDoS attacks, where it would ask the other computer to target a server simultaneously, overwhelming its resources. Then Keylogger, we covered it earlier. It's a software that records all the keystrokes, and it can even steal the passwords. Then we have RAT, which is remote access Trojan, malware that provides or which covert the surveillance and unauthorized access to victim species like remote access Trojans for espionage, etc. Then we have bloatware, unwanted software that included on a new computer or a device pre-installed trial software, which slows down the new laptop and stuff like that. You might have seen there are lots of bloatware which comes in with the laptops if you'll purchase, or most of the mobile phones which are purchased, they come in installed with that. Then we have web-based attacks and application vulnerabilities. Just like applications, endpoints, we have vulnerabilities in the web applications as well. Now, first of all, we'll have to understand what is a cross-site scripting. It's an injection of malicious scripts into otherwise being entrusted websites, stealing the cookies via the cross-site scripting to hijack the session. Now, you might see that someone would send you a file, and that file would open certain access or would give access from your browser to the other person. So that session which is being active, they can gain access to all your passwords and rest of the things. That's called cross-site scripting. SQL injection is inserting and injecting an SQL query via input data from the client to the application, retrieving the entire database via SQL injection. So instead of entering a username and password, if a user enters a script and it's not properly handled in the application, they can pass in a script over there which would show all the tables of the database or maybe the username and password of the users. Now, cross-site request forgery is an attack where it forces an end user to execute unwanted actions on a web application in which they are currently authenticated. A malicious email that tricks a user into changing their email address on their profile, etc. Then we have server-side request forgery, which is exploiting the server to make requests to internal services, accessing the cloud-based metadata to steal the credentials. Then we have replay attacks, which are the network attacks in which the valid data transmission is maliciously or fraudulently repeated or delayed, like reusing valid sessions tokens to impersonate the user. That's why you might have seen most of the cases that if you're using any banking websites or the financial websites, they ask you to close the browser also after you'll sign out from the session, just to make sure that all those cookies are cleared out from the cache of the browser, just to make sure that no one else can gain access to that. Then we have directory traversal attack, which allows attackers to access restricted directories and execute the commands outside the web server root directory. For example, accessing the etc passwords directory or through the poor input handling. So in that way, maybe you have certain files which are kept for downloading. If it is not properly handled, maybe the user would hop back to the main root directory where you have all those folders. They'll be able to browse through the folders and can see the data which is copied in that. Then we have buffer overflow attacks. These occur when a program or a process attempts to write more data to a fixed length block of memory or buffer than the buffer is allocated to hold. Now, overrunning the buffer boundary and overwhelming the adjacent memory would make the application unstable, or maybe the application would fail. So it's called in buffer overflow attack. Then we have privilege escalation. It's an attack which exploits the bugs, design flaws, or configuration oversights in an operating system or the software application to gain elevated access to the resources. Exploiting a flaw to gain the admin privilege on the network would result in executing admin level commands on the remote servers on the server itself to make all the necessary changes which are required. Then we have indicators and response to the attacks. We have indicators of attack, host intrusion detection systems, host intrusion prevention systems, and endpoint detection and response. So indicator of attacks are the sign of anomalies that suggest an attack is occurring or has occurred. Usual outbound network traffic activity would show that maybe it's an indicator of attack, because all of a sudden you'll see that files in gigs would be uploaded from your network to the external entities. Then we have host intrusion detection systems, softwares that monitor, detect, and alert on malicious activity in a host. It alerts, triggers unauthorized file changes or anything. So that's a host intrusion detection system, which is constantly detecting any sort of suspicious activity which is taking place on your network, and it would alert or would trigger email to the persons who are responsible to have a look at what's going on. Then we have intrusion prevention systems, software systems that are not there to detect but also to take action to prevent the identified attack. So they are smarter than intrusion detection systems. Intrusion detection systems just detect it, but prevention system would detect and prevent it as well. They automatically block suspicious processes and activities and would inform the administrators about any suspicious activity which is there. Now, endpoint detection and response systems, tools that continuously monitor endpoints to detect and respond to cyber threats using EDR to track and stop the ransomware attacks before they spread. So they are even smarter than HIPS, which is host intrusion prevention systems, because it would be collecting data from all sort of different places. It would learn the pattern of users, how they use the systems, and if any actions deviate from the baseline configuration settings, etc., it would detect it and it would try to protect the systems against it. Now, this is our last slide, which is talking about protecting the endpoints. In order to protect the endpoints, we must have antivirus and anti-malware software designed to detect, prevent, and remove the malwares from your systems, like antivirus software scanning and removing the viruses, etc. Then secure cookies that are configured to enhance the security by restricting access to only encrypted sessions. So it would not keep any information which could be later decrypted. Cookies with the secure flag set in a web application. HTTP response headers, like the security enhanced headers on the web server used to protect the users against certain type of attacks like X-frame options or preventing the click hijacking, etc. Hardening the endpoints, techniques to reduce the vulnerabilities in softwares and prevent unauthorized access or execution, etc. by disabling the unauthorized or unused ports and services on endpoint devices. As we told you, that if you're using any web server, just make sure that you are not enabling all the services which are not required. So only those ports shall be enabled on those web servers which you'll be using. Now, regular updates and patch management is really important to practice and keeping the software and computers update on the devices and patched. Automatically applying the security patches would ensure the vulnerabilities are properly addressed and promptly. So that was our lecture on endpoint vulnerabilities, attacks, and defenses.